This is the page 535. Problem 48. We have the sine of the 34 degrees times cosine of the 13 degrees plus cosine of the negative 34 degrees and times sine of the negative 13 degrees. So first, let's simplify this part. We know the cosine is even function, so cosine of negative 34 degrees is equal to cosine of the 34 degrees, right? And sine is odd function, so sine of the negative 13 degrees is equal to negative sine of the 13 degrees. So you have the minus here. So now, tell me which identity should I use? Which one? Sine or cosine? First tell me. Identity for sine or for the cosine? Sine. Sine of a sum or the sine of a difference? Sum or difference? Difference, right? So this is equal to sine of alpha times cosine beta minus the cosine alpha times sine beta. So this is a sine of the alpha minus beta. So alpha 34 degrees, beta 13 degrees, and then you subtract, you have the sine of the 21 degrees. And in this way, we simplify this expression. Now let's look at the problem 50. Okay, let me copy this problem on the whiteboard. Cosine of the 12 degrees times cosine of the negative 3 degrees minus sine of 12 degrees times sine of negative 3 degrees. Now tell me which identity should I use? Sine or cosine? Cosine, right? Cosine of a sum or the difference? Difference or sum? Sum, right? Cosine of the alpha, actually, let me write here. Cosine of the alpha plus beta is equal to cosine alpha times cosine beta minus sine alpha times sine beta, right? Here, this is a minus. So, and these two parts have the same angles. So we should use the cosine of a sum. So you have the cosine of the 12 degrees plus negative 3 degrees. And then finally you have the cosine of 9 degrees. Now let's look at the problem 66. Find the exact value of the cosine of the alpha minus beta given that cosine alpha is equal to root of 3 over 4 and cosine beta is equal to negative root of 2 over 3 with alpha in quotient 1 and beta in quotient 2. So this is the page 535, problem 66. We know the cosine alpha equal to root of 3 over 4. Cosine beta equal to negative root of 2 over 3. And alpha is in the quadrant 1, and beta is in the quadrant 2. Okay, so we need to find the cosine of the alpha minus beta, and we know by this identity we have the cosine alpha cosine beta plus sine alpha times sine beta. Right now we know the cosine alpha, we know the cosine beta, right? And we need the sine alpha and sine beta. So let's get the sine alpha. And alpha is in the quadrant 1, so sine alpha is positive, right? So this sine alpha is equal to positive square root of 1 minus the cosine square alpha by the fundamental identity. So this is equal to the square root of 1 minus the square of root of 3 over 4. And this is equal to 1 minus 3 over 16. And this is equal to 13 over 16. And then take the square root. So this is equal to root of 13 over 4. Right? And now let's look at the sine beta. Sine beta, beta is in the quadrant 2, so sine beta is also positive. So this is equal to the square root of 1 minus cosine square beta. So this is equal to square root of 1 minus the square of negative root of 2 over 3, and this is equal to 1 minus root of the 1 minus 2 over 9, and then this is equal to 9 minus 2, you have 7, so 7 over 9, and then you have root of 7 over 3. So now after we find both the sine alpha and the sine beta, then we can get the cosine of the alpha minus beta. So cosine of alpha minus beta by this identity, that is equal to cosine alpha root of 3 over 4 times cosine beta negative root of 2 over 3, and plus sine alpha root of 13 over 4, and times the sine beta root of 7 over 3, and simplify. So 7 times 13 is equal to 91, so you have the root of the 91, 3 times 4, 12, and then here root of 3 times root of 2, root of 6, and over 12. Or you may write this as root of 91 minus root of 6 over 12. Then down. Okay, now let's go to the page 536 and let's look at the problem 88. We need to verify this equation is an identity. So 88.